What keeps a skyscraper from folding under its own weight, or a house from collapsing in a storm? It's not just strong materials. It's a clever system of forces, paths, and shapes working together. Today, we're breaking down 5 essential structural systems that make buildings stand up and stay standing. Once you see how these systems work, buildings stop looking like static objects and start looking like problem-solving machines. And that's useful, because understanding structure helps you spot why some buildings are efficient, why some fail, and how architects and engineers make smarter choices. The simplest system is the load-bearing wall. These walls do 2 jobs: they separate space and they carry weight from the roof or floors above down to the foundation. The mechanism is straightforward. Loads move vertically through the wall into the ground. That makes this system strong and efficient for smaller buildings. A lot of older homes and low-rise buildings use it because it's simple and economical. But there's a trade-off. Load-bearing walls limit open floor plans, because you can't just remove them without changing how the building stands. Next is the post and beam system, also called a frame. Instead of the walls carrying the load, columns and beams do the heavy lifting. Think of columns as vertical legs and beams as horizontal bridges. The advantage is flexibility. Walls can be placed almost anywhere because they're no longer structural. That's why this system is common in offices, schools, and modern homes with open layouts. A concrete example: if you want a wide living room with fewer interior walls, a frame system makes that possible. So far, we've mostly talked about gravity, but buildings also have to fight sideways forces from wind and earthquakes. That's where shear walls come in. Shear walls are stiff vertical walls, often made of reinforced concrete, masonry, or structural wood panels that resist lateral movement. Mechanically, they act like a brace, preventing the building from swaying too much. You'll often find them around stairwells, elevator shafts, or as core walls in tall buildings. Useful example: in an earthquake-prone area, shear walls can be the difference between a building that merely rocks and one that twists dangerously. Another way to handle lateral forces is the braced frame. These use diagonal members, creating triangles, the most stable shape in structures. Why triangles? Because unlike a rectangle, a triangle doesn't easily deform without changing the length of its sides. That makes braced frames very efficient at transferring wind and seismic forces down to the foundation. You'll often see this in warehouses, towers, and industrial buildings, where strength and efficiency matter more than having completely open walls. For tall buildings, engineers often use tube systems or strong central cores. In a tube system, the building's outer perimeter acts like a hollow tube resisting wind from the outside. A core system uses a stiff central spine, often around elevators and stairs, to stabilize the tower. This is incredibly useful in skyscrapers because as buildings get taller, wind becomes a major issue. Without a strong lateral system, the top of the building could sway uncomfortably, or worse, become unsafe. A real-world example: many modern high-rises combine a central core with perimeter framing to balance strength, flexibility, and usable interior space. What's fascinating is that every building is a compromise. You want strength but also open space. You want stiffness but not too much material. You want safety but also cost efficiency. Structural systems are how engineers solve those trade-offs. So the next time you walk into a building, ask yourself, what's really holding this up? Is it walls, a frame, diagonal braces, a stiff core, or a combination of all 5? Because once you understand the structure, buildings stop being just places. They become visible answers to invisible forces. How buildings stand up. 5 essential structural systems is just one small part of structural systems. If you're interested, our full free structural systems course is linked in the description.